Greetings, and welcome to this episode in the series of videos on working with remote sensing with ArcGIS Pro. This series is brought to you by AmericaView in partnership with Virginia Tech, the Virginia Cooperative Extension, and Virginia View. I'm Cherie Aukland, and I'll be your guide. This video tutorial series builds on ongoing and previous collaborations and contributions provided by the USDA NIFA through the ADVANCE project, the National Science Foundation, through the GeoTED UAS project, the Ohio State University, and the Virginia Space Grant Consortium. This video series is associated with the Remote Sensing with ArcGIS Pro 2nd Edition book. We will use Landsat 9 imagery in this series, and we'll also begin with Chapter 10. Links to resources for this video series, including free access to the textbook and to the videos for Chapters 1 through 9, are available in the video description below. The next 3 chapters introduce image enhancement techniques using ArcGIS Pro. Image enhancement is processing remotely sensed imagery to adjust the brightness values of the individual pixels to improve the image's visual qualities, such as color balance, brightness, contrast between pixels, or other characteristics for a specific purpose. Most remotely sensed images require some form of image enhancement to help reveal features not visible in the unenhanced version. See your textbook for a complete discussion on image enhancement, including histogram enhancement techniques and digital enhancement techniques. Our focus in this chapter is radiometric enhancement. We begin with the Chapter 16 ArcGIS Pro project, removing all but the Landsat 9 clipped composite image of bands 2 through 7 created in Chapter 15. Note that I have the image displayed in color infrared, which we demonstrated last chapter. Now ensure you have your composite image selected in the contents and go to Raster Layer on the ribbon. Let's review the enhancement icons for brightness, contrast, and layer gamma. The values you see here may differ as the software sets the default values. These 3 enhancement tools are adjusted using the slider, the up and down arrows, or by typing a numeric value in the box. Let's experiment with each tool and observe the changes reflected in the display. Layer brightness will make the image appear lighter or darker. The default value is 0. Values can range from negative to positive. Let's change this value to -30 so you can slide it. Notice how the image is getting much darker. And sliding back to positive values will brighten the image. You can click the icon here to reset it to 0. Layer contrast changes the range of differences between the darkest and lightest objects. Here, the layer contrast value is set to 10, and the slider bar you'll notice isn't centered. ArcGIS Pro automatically sets the layer contrast based on the image's pixel values. If you're using a different image from mine, again, you may see a different value. Layer contrast also has an adjustment range that includes positive and negative numbers. Let's try a couple of settings. I'm going to type -35 here. Notice that the image appears to be darker, but it's actually not as sharp. The contrast has been muted. Now if we increase the value to +35, I just hit enter there, this looks much better. This setting has sharpened the difference between land and water bodies, for example, which are the darker colored features. Go ahead and try some other settings. Remember to reset the values to default when finished, and for layer contrast, the default is 0. Layer gamma values range from 0 to 10 and control the relationship between the brightness of the original scene and that on the display. For example, at a gamma of 1.0, the 2 images will use the same brightness scale, whereas at a gamma of 0.5, so let's go down to 0.5, or 1.5, I'll type that in and watch how the display changes. The display shows either compressed or expanded brightness rankings relative to the original. For our image, ArcGIS Pro determined that 1.5 was the best setting. Now let's reset the gamma value to its default setting, and let's look at another tool. The Dynamic Range Adjustment tool adjusts an image dynamically in the viewer when zooming in and out. The stretch type doesn't change, only the range of values changes based on the portion of the image in the viewer. The contrast stretch occurs seamlessly as the user pans around or zooms in or out of the image. Let's turn on DRA and see what happens in the viewer. The DRA-enabled view of the entire scene is visually no different from the image without DRA enabled because it uses the same statistics as the entire dataset. The difference in the image display occurs when zooming in. Let's turn off DRA here and zoom in to Carvin's Cove. I'm going to use a bookmark here. Now toggling DRA, watch what happens in the screen. Raster layer, DRA. The image is sharper, especially the boundaries of the water body. The clouds have diminished a bit. Let's try a different area. Let's turn off DRA. I'm going to zoom to the entire layer. And we're going to zoom to this area of the city of Roanoke. Now let's enable DRA. The outlines of the buildings are clearer with DRA enabled. These tools are helpful when conducting image classification to help discern features in the image. Let's set our image enhancement tools, both gamma, contrast, and brightness, back to their original values of 0, and in my case 10, and 1.5. Recall from your text, histograms plot the frequencies of brightness values with the digital numbers along the x-axis and the number of pixels associated with each digital number on the y-axis. Changing the stretch type changes the histogram and the image's appearance in the map viewer. Let's go to the raster layer tab, drop down stretch type, and here's a list of the stretch types and descriptions of each one. We'll discuss the most often used stretch types, beginning with %clip, which you can see is highlighted here and is the default. In symbology, let's ensure %clip is the stretch type. You can change it here using the drop-down if you need to. The minimum and maximum ends of the histogram were clipped by 0.25. These values can be changed. Let's change it to 0.8 for each of the ends and watch what happens in the display as I do this. The map viewer here shows a pretty substantial change, especially around this urban area. The statistics haven't changed from the original setting because statistics are based on the dataset values, and this image is based on the values in the viewer. Remember, this is dynamic range enhancement. Now to view the result for the entire dataset, you can drop down statistics and choose dataset. Much different. Here the basis of statistics can be changed. To set custom statistics, you must select a stretch type other than %clip and ESRI. Let's change the stretch type to see how this modification changes the image. First, I'm going to zoom out a bit to all of Roanoke. I'm going to use my handy-dandy bookmark. And now let's go back to the stretch type and change this to minimum maximum. Notice now the minimum and maximum % boxes are gone under here. Again, the statistics are still the same because they're based on the original brightness values in the image. We're looking at the dataset now, not DRA. Let's drop down the statistics now, and you'll see custom. You can change the numbers for each band now. Remember that a 16-bit image has values from 0 to 65,535. In this image, the near-infrared band, which is displayed in red, has values ranging from 5,523 to 65,535. Your values may differ depending on your selected area of interest, in other words, the area that you clip. Let's change the minimum value to 0 for red and watch what happens in the viewer. As you can see, the appearance of the image changed a little bit, but the brightness was not enhanced. So when changing the statistics, should these be changed to 0 and 65,535? Since this is a 16-bit image? Well, the answer for this image is no, but it may work on a different image as the range of values for any single band is contingent on the project for which the image is being analyzed. You can reset the statistics by changing it back to dataset and %clip. I'm also going to change the minimum and maximum here for %clip to 250, which was the original value, so we can get back to the original image. For this next part of the discussion, be sure you're zoomed into Roanoke and select DRA from Statistics And now you can see the image has changed to reflect the range of values in the extent of the image in the viewer. Notice gamma is also present. All the settings for different forms of radiometric enhancement can be changed. These options do not need to be changed independently of each other, so after adjusting stretch type settings for any stretch type, brightness, contrast, and gamma can also be adjusted. Now explore the various methods of histogram stretch with different band combinations. Which method is best will depend on the purpose of the project and likely a decision the analyst makes during the image analysis process. It's really important to note that the goal of this chapter and subsequent chapters is to summarize the methods and techniques available in ArcGIS Pro and not to advise on which techniques to use or which techniques are best. Now, to view the histogram associated with a particular band, be sure you've selected the Composite Image Raster and Contents and go to the Data tab on the ribbon. We're going to create a chart and choose Histogram. Notice there are several. And here you see the empty histogram chart and the chart properties pane open on the right-hand side. Let's select a band from this drop-down. Notice you only see 432, which are the bands that are currently displayed. Let's choose band 4. The blue line on the histogram is the mean line, because mean is the only statistic checked in chart properties. Let's turn on median and standard deviation to view those stats on the histogram. If you want to change the format of the histogram, you can use the Axes and Format tabs. But let's go back to the Data tab and change the band number to band 3. Notice what happens in the histogram window. The histogram associated with band 3 looks very different from band 4's histogram. Recall the discussion about band combinations from your text, and that each band contains the data collected from a range of the electromagnetic spectrum, and each of these bands has a unique set of values. The variation in histograms between the different Landsat bands we just reviewed demonstrates these spectral variations. If you need to save your histogram as a figure in a non-GIS format, click on Export in the chart window and choose one of the 3 export formats. This ends the chapter on radiometric image enhancement. Next up is spatial enhancement in Chapter 18. Spatial enhancement is based on the values of individual and neighboring pixels.